Hello friends, the objective of today's tutorial is to find similarity between remainder modulo A and remainder modulo B. So that means, let's say I have some integer n and n modulo B is, let's say, some number p. Now from this, what can I say about n modulo A? That is the question, right? So now let's consider first case where I'm taking value of b is equal to 4 and value of a is equal to 2, and I have considered 11 different values of n starting from 0 to 10, and you can check the corresponding remainder values. So if I take 0 modulo 2, then I will get 0. Similarly, 1 modulo 2, 1, 2 modulo 2, 0, and so on. Similarly, with respect to modulo 4 operation, 0 modulo 4, 0, 1 modulo 4, 1, 2 modulo 4, 2, 3 modulo 4, 3, 4 modulo 4, 0, and so on. So now let's talk about one particular scenario where I am fixing, let's say, n is equal to 5. So if n is equal to 5, then I am talking about, and I'm considering the value of b is equal to 4 here, right? So I'm talking about 5 modulo 4. So 5 modulo 4 is corresponding to this number, which is nothing but 1. Given this information, what can I say about 5 modulo 2? This is the question. Okay. So similarity between n modulo 4 and n modulo 2 depends upon how specifically can I answer this particular question. Okay, so now let's analyze further. So if I talk about modulo 2, then basically this is corresponding to my first set. Let's say set 1 contains only 2 possible answers, which are nothing but 0 and 1. And if I consider set 2, which is corresponding to modulo 4, then there are 4 possible answers, namely 0, 1, 2, and 3. And if I consider all possible answers with respect to reminders, then I will get this 2 into 4, which is nothing but 8 pairs: 0, 0, 0, 1, 0, 2, 0, 3, and similarly 1, 0, 1, 1, 1, 2, and 1, 3. But if you observe carefully, then out of this 8 pairs, only 4 pairs are present in this table, right? So let's verify. You can check 0, 0 is present, right? This so 0, 0, this first combination is present. 1, 1, this combination is present. 0, 2, this combination is present. And 1, 3, this combination is present. Other combinations are not possible, right? You can verify this. 1, 0 is not present, 0, 1 is not present, similarly 0, 3 is not present, and 1, 2 is not present. So that means out of 8, only 4 combinations are possible. And from this, can we answer something? So now let's analyze this further. So if I consider on only these 4 entries, then it is saying me 0, 0. That means if so the first column here is corresponding to my set S1, which is nothing but modulo 2, and second column is corresponding to modulo 4, which is nothing but my set 2, right? So if I analyze, then if my number is even, then I will get this 0 as well as this 0. And if my number is 0, if my number is even, then with respect to modulo 4, I will get 0 or 2. So we can analyze this. So you can see here number is even, so I am getting 0 in both the cases. Second, number 2, modulo 2 is 0, modulo 4 is 2. One more number if we can take, then 4, with respect to 4, both are getting 0. So the idea is, if my number is even, then modulo 4 will give 2 probable answers, right? Either 0 or 2, and modulo 2 will be always 0. Similarly, if we analyze this unit, then again we can say that if number is odd, right, then modulo 4 will give answer either 1 or 3. We can see here, for 1 answer is 1, for 3 answer is 3, for other odd numbers like 5 answer is 1, 7, answer is 3. So either we are getting 1 or 3, right? And corresponding number with respect to modulo 2 will be nothing but 1, because for odd numbers we will get just 1 as the answer whenever we apply modulo 2. So that means in this particular case, if I am saying 5 modulo 4 is 1, then I am sure that this particular number, corresponding number with respect to modulo 2 will be nothing but 1, right? I can answer this. So let me take one more example. Let's say 7 modulo 4. So 7 modulo 4 is 3, and from this I am asking what will happen if I take modulo 2 instead of 4. So I know that with respect to modulo 4, if I am getting 1 or 3, then with respect to modulo 2, I will definitely get 1. So I can specifically answer, right, irrespective of my selection of number n. So from this, I can conclude that n modulo 4 defines n modulo 2. And further, what I can do is I can take two numbers. So let me take number 1 and 5, right? So with respect to 1 and 5, what I can say, so I have two selections now. So my n1 is 1, n2 is 5, right? And now let me just do this particular exercise. I am finding out n1 modulo b, I am finding out n2 modulo b, and then I am finding out what is n1 modulo a, and I will also find out n2 modulo a, right? So with respect to these four numbers, I will find out these four quantities. So let me just substitute values. So 1 modulo 4, right? So this is nothing but 1 modulo 4 is nothing but 1, and the next number is 5. So 5 modulo 4 is nothing but 1, right? So these two values are same. n1 modulo b is equal to n2 modulo b. So in this particular case, what can we say about n1 modulo a and n2 modulo a? So value of a is 2 now. So now let's just check the corresponding numbers, right? So now we are talking about 1 modulo 2. So 1 modulo 2 is 1, okay? And then we are talking about 5 modulo 2, which is again 1. So that means what we are saying here is, if this is the case where the first entity, which is nothing but n mod b, defines n mod a, then if we can find out two numbers for which modulo remainder answer is same, then with respect to the second number a also, the modulo remainder a answer will be same. Okay, so this will become clear when we consider more examples. So let's go further. Now this is all about case 1. Now let me consider case 2. So now instead of 4 and 2, now I'm considering 5 and 2. Okay, so again, so if we consider all possible scenarios, then with respect to 2 we can get only two values, which is nothing but 0 and 1. With respect to 5 we can get this 5 values, and again the question is same. Can we, given that let's say n modulo 5, if I give you some answer, let's say n modulo 5 is some number, let's say 1, from this what can I say about n modulo 2? This is the question. Okay, and if we can answer this specifically, then we can say that n modulo 5 defines n modulo 2, right? Okay, so now let's analyze. So with respect to this, there are several possibilities. So let me just list it down: 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and with respect to 1, we'll have similar type of possibilities, right, of reminders. So basically, I'm just listing down these pairs. How many array is corresponding to possible value of remainder when we divide a particular number by a, and RB is nothing but possible value of remainder when we divide number n with b, right? So there are two choices with respect to a, and there are 5 choices with respect to b. So we have 10 different combinations, 10 different pairs of RA comma RB. And now if we notice, then all these 10 pairs are present here. We can just verify 0, 0 is present. Now next one is 1, 1. So 1, 1 is present. 02 is present, 13 is present, 04 is present, then 10 is present, 01 is present, 12 is present, then 03 is present, and then 14 is present. So that means everything is present. So that means there is no reduction in terms of number of possibilities. So if I say n modulo 5 is 1, then in this particular scenario I can't say anything about n modulo 2, right? So in that sense I can say that there is no dependency, right, here in this particular case. Right? If you recall, then in the previous example, there was straight away deduction in terms of number of choices. There were 8 possibilities, and out of those 8 possibilities, only 4 possibilities survived. But in this particular case, all the possibilities survived. So if I, so let me take some concrete example. So let's say my number is 6, and I am saying 6 modulo 5 is 1. So what can you say about 6 modulo 2, right? So here again we are not supposed to apply the modulo arithmetic by your own, but can we correlate 5 and 2 with respect to this modulo operation? That is the question. So whenever we are getting 1 as the answer in with respect to RB, there are again both the choices are there. One is also there, and 01 is also there. So we can't say specifically what will be the answer with respect to modulo 2. So there is no correlation between these two. Okay. So now let me consider one more example. So you can verify this is corresponding to 6 is corresponding to 01, right? And there will be a case like this 1 is corresponding to 1, right? So you can see the 1 remains constant here, right? So if I rewrite, then what I'm trying to say here is 1 modulo 5 is equal to 6 modulo 5, but 1 modulo 2 is not equal to 6 modulo 2, right? Whereas if you recall, then in the case 1, right, this relation was survived. Now let me consider the third case. Now b is equal to 6 and a is equal to 4, and again we can do the similar exercise. We can list down all possible 24 pairs of type RA, RB, and out of those 24 pairs you can check roughly. So let me do this particular exercise. So 0 is there, 1 is there, 2 is there, 3 is there, 04 is there, and then 15 is there, 20 is there, 31 is there, then 02, 13, 24, 35, and after this point the repetition will come, because the next number is 12, and if I do 12 modulo 4, then 0, and 12 modulo 6 is also 0, right? So you can see 12 pairs are appearing out of this 24 pairs. Okay, 12 combinations are appearing. So now let me ask one question. Let's say I'm fixing n is equal to 6, and I am saying n modulo 6 modulo 4. Sorry, now I need to consider 6 modulo 6. So 6 modulo 6 is 0, right? 6 modulo 6 is 0. From this, can you say anything about 6 modulo 4? That is the question, right? So if I give you some reminder, so let's say I am saying reminder is 1 after performing modulo 6. Can you say anything about what will be the reminder if you perform modulo 4 operation, right? So that is the question. If we can answer this specifically, if we can give just one number, then we can say the dependency is complete. Otherwise, we will, if we can predict some answer, if we can eliminate some of the possibilities, and we can give some of the options, then we will say this n modulo b is dependent upon n modulo a, not completely dependent but somewhat dependent. So let's try to answer this. Let's say after applying modulo 6 my answer is 1. So what can I say with respect to modulo 4? So let's see where I am getting 1 as the answer. So here for n is equal to 1 answer is 1. Then for n is equal to 7 also the answer is 1. But if you notice, then corresponding values for n is equal to 4 is 1 as well as 3. So here I can say modulo 4 answer will be either 1 or 3. I can't answer specifically, just like case 1. If you consider case 1, then in case 1 I can answer specifically that answer will be 1 if modulo 4 if modulo 4 answer is 3, then I can say modulo 2 answer will be 1. If modulo 4 answer is 1, then I can say modulo 2 answer will be 1. If modulo 4 answer is 0, then I can say modulo 2 answer will be 0. If modulo 4 answer is 2, then I can say modulo 2 answer will be 0, right? So I can answer specifically in case 1. Whereas in case 3, I am eliminating some of the possibilities. For example, in modulo 4, there are 4 possibilities, but out of 4 possibilities, I am reducing it to 2 possibilities, right? So there is some dependency. So therefore, we will say that n modulo b depends upon n modulo a, right? Or more concretely, we can say n modulo b defines n modulo a, but not completely. Okay. So now from this discussions, it is clear that this case 2 is different, and if we notice, then GCD of a comma b is equal to 1 in this particular case. There is no common factor, and hence there is no dependency also, right? Because if some answer is given, right, with respect to modulo 5, then we can't say anything about modulo 2. That is the case here. We can take other numbers also for getting better insights. For example, I can also take a is equal to 3, then also the same result will be true. If we observe the first case, then in the first case, basically a divides b, right? In the first case, a divides b. In the second case, GCD of a comma b is 1. And in the third case, something in between is there. If we notice, then GCD of a comma b is 2 here, right? So there is some common factor involved in this particular third case. So from all this, we can say something, right? Say something concrete. So the first result is, or first theorem is, if n1 and n2 have same modulo reminders, okay, so same reminders after performing this modulo b operation, let's say, and second condition is a divides b, then we can say that n1 and n2 will have same reminders with respect to modulo b operation, modulo a operation also. So now let's prove this. Okay, so the criteria is we have two numbers. Okay, so the given thing is we have two numbers n1 and the second number is n2, and if you perform mod b operation, then the answer is same, right? So if you perform mod b with respect to n1 and with respect to n2, then you will get the same answer. So in other words, I can write the same fact like this: n1 congruent n2 mod b. In other words, I am saying that n1 minus n2 is multiple of b, right? Some k is here, right? So that means I can say that b divides n1 minus n2, right? So basically, if we simplify this, then let's say some remainder is r, then r is equal to n1 mod b, right? So from this we can say n1 is nothing but some k times, so let's say k1 times b plus r. Similarly, we can write like this: n2 is nothing but some k2 times b plus r. And now if we perform n1 minus n2, then we will get k1 minus k2 times b. So basically b divides n1 minus n2. And now it's given that a divides b. So since a divides b and b divides n1 minus n2, from transitivity we can say a divides n1 minus n2. So that means from this we can say that if we perform modulo a operation with respect to n1 and n2, then we will get the same answer, right? So this is all about case 1, right? So for case 1 we have already observed this thing is happening when we take two different values, and with respect to one modulo, let's say with respect to modulo 4, if our answers are same, then with respect to modulo 2 also our answers will be same. Now in the next lecture we'll explore this particular criteria where these two a and b are independent because they are co-prime, and we'll try to extend this result, right? And that will be nothing but Chinese remainder theorem. Thank you. Subscribe to my channel for more videos.